I've instructed you to take a look at a picture and slide all of the points on the graph down to the x-axis and tell me how much of the x-axis is being covered. How much of it's being covered. This thing gets wider and wider and wider and wider forever and ever and ever. It's covering everything, isn't it? So, I need you to look at choice A through D and tell me which one of them says, cover it all. D, that is true. Nicely done. Now they're asking me about the range. Now, range, we said, take all the points and slide them to the y-axis. How much of the y-axis would get covered if we did that forever and ever and ever? I don't know. I don't know what B is because I'm not staring at it. And you might be right. I don't know. I got to look at it here, but it looks like it should be everything from 0 on up, doesn't it? So, is that B? Oh, okay. Nicely done. Did I miss something, Mr. Minka? Did I miss something? I mean, cool or funny or... It probably was. I just didn't hear it. Sorry. Okay. Last thing they want to know is that a function? Okay. So you're saying it passes... Whoa. It disappeared. Sorry. I got to lock it first. If I don't lock it, then I can't write on it. Does it pass the vertical line test? Yes, it does. Okay, so that passes the vertical line test, so it is a function. Make sure that you are noting why. Okay, simply choosing yes does not help you. Question 10, I'm going to rewrite slightly. Okay, so this function, I'm not asking you to memorize that. There's no reason for you to memorize that. So I'm going to write it with the Euler's function notation that you and I talked about yesterday. Okay, it is V of R. In other words, volume, as it depends on the radius of a sphere, is found by taking 4/3 times pi r cubed. Okay? This is kind of like that idea that we were talking about yesterday with f of x, or g of x, or h of x. Okay. Evaluate the function for the volume of a volleyball with radius 10.3. So what are we doing with that? What are we plugging that in for? Ah, the radius. Thank you very much. So the volume for a radius of 10.3 is what? Use your machine right now and figure it out. Use your machine right now, because none of us are going to be able to do that without a machine. Use thy machine. Alright, so when you type that into a calculator, what'd you get? I'm hoping you got something like 4,577.2 approximately. Now, if you didn't, then I know what you did. If you have a Texas Instrument calculator, The majority of the Texas Instrument calculator require you to use parentheses around a fraction like this. I have seen a couple Casio calculators that will create a vertical fraction like you see on screen right now, and if it does create a vertical fraction like you see up there, then it pretty much takes care of the parentheses for you, and it will be fine. But if you have one of the Texas Instruments, now the other way to get around it with Texas Instrument calculator is to do this part first, then multiply times pi, then multiply times 4/3. But if you want to type it all in one giant step, which some of you like to do, I would suggest you use parentheses around this fraction right here. Okay? So that 6-1 should be out there if you want it. Any questions on how you were using it on your calculator? Especially if you didn't get 4,577.2. I'd like to look at your machine and see if I can help you. In question 1, part A, one notation that you might see looks like this, but I'm going to write it a different way, which might make a little bit more sense to you. This is not the distributive property, but it kind of reminds me of that. I need you to think like this. We are literally going to take these two functions and add them together. Now, do you remember when you were in elementary school and we were adding 3-digit numbers together? We would put the 1s in the same column, we would put the 10s in the same column, we would put the 100s in the same column, all that good stuff. We're going to be doing the exact same thing, but with these polynomials. It's not really complicated, I just kind of wanted to remind you of that. So if you're asking me to add 4x plus 6 and 2x plus 4, I would really like it if you would line them up in like columns. Because I have a feeling you'll get the answer right. What do you get? 6x plus 10. It really is that easy. Okay. Yes, I did not capitalize anything in that sentence. Okay. Last year's students. At first, when they said that, I thought it was a description of the next Marvel movie for the Avengers, but I'm pretty sure they'll pass that on to somebody else. I guess he already did, didn't he? Yeah. All right. Now, do you trust your answer for part A? If you trust your answer for part A, what are you going to plug in to find the answer to letter B? Looks like we're supposed to plug in a 6. If you trust your answer. Now, if you don't trust your answer, I'm going to show you a different way to do it. And for those of you who want to check your work, this is not a bad way to check your work. Okay? We could go back to, freeze this, we could do f of 6 plus g of 6. In other words, we could plug in 6 into this one. we could plug 6 into this one, and then we could add those together. Now, I know that there are a lot of you in this room that would rather just trust your answer to part A, even if it's wrong. Because you look at this stuff in the red over here, and you're like, oh my goodness, 24 plus 6 is 30, and 12 plus 4 is 16. That's just too much work. Okay? But in either case, whether you do this one or this one, right, you're still going to get 46. But it's a good way to check your work. Okay, let's look at question 2. Part A. Adding the two functions together. What do you get when you add those two, this function together with this function? Alright, so we got 3x squared is... No, you're not wrong, but I need to show them something. So hold on to what you're saying. Is the x that I'm pointing to with the blue, is it a like term to the 3x squared? No, so I'm going to put it in its own column. Remember we talked about the hundreds and the one and the tens and the ones? How about the 8 that I'm pointing at right now? Is that a like term to either the 3x squared or the 1x? No, so I'm going to put it in its own. So when you add these two things together, what do you get? Which is what you were quoting me, sir. You were right. See, there's no way to add any like terms together here. At all. It's really kind of hard to mess that one up. How about this? What am I supposed to plug in for x? Okay, do it. Okay, so 3 times 4 squared? Alright. So 3 times 4 squared. You do have 4 squared is 16, but we want 3 times that. So that's the 48, right? The 4 and the 8 can be added together and give me 12. And so overall, what do we got? 60. Good answer. Good answer. Lots of good work going on there. I saw several of you with that answer. Okay, we're going to skip 3 for right now and come back to that one later. Okay? I want you to shift your thinking down here to number 4 because it's subtraction. And you guys generally do really well with addition, and then a couple mistakes come in when we come to subtraction. So we need to practice this. So I'm going to write this out. It says right here, f of x minus g of x. We really need to think about it separated like that. So the f of x function, x squared minus 3x, minus 9 minus x. Now, I need you to realize those parentheses that I put in there are extremely important. Several of you forget to put those in there, and it causes a problem. And I'll show you why here in a minute. What number is right here that I'm highlighting in the red, but in front of that parenthesis? That is a negative 1. Now, we never write the 1 in there, but we know it's there. This is going to get distributed to both of these things. Now, just down here below, I'm going to write this in blue. We start out with x squared minus 3x. When we distribute this negative 1 to the 9, what number does that create? Negative 9. Is that a like term to either one of the terms I've written down in blue? Is negative 9 a like term to either one of those? No, so I'm going to put it in its own column over here. Then I distribute the negative 1 to the negative x. The negative 1 to the negative x. What do you get? When you distribute the negative 1 to the negative x. It is negative 1 times negative x. Positive x. Is that a like term to any of the three? Yeah, it is. So put it in its same like column. Now, because you and I distributed that negative 1, we have changed this. It is no longer subtraction. What operation did we just change it to? Addition. Addition. So now we are adding the terms together. We are adding the terms together. And you guys are really good at doing this. All right? I don't see very many mistakes when you guys get this switched over to addition. So we would get x squared minus what? Minus 2x. Now, what I end up seeing, the people who forget the parentheses always end up telling me that that middle value is negative 4x. They have the wrong sign on that lower term for that positive x, and they end up getting that middle term wrong. And if you get that answer wrong, what's going to happen for the next part? More than likely, you'll get that one wrong because you used the answer previously. Remember at the beginning I said, if you trust your answer, then use it. So this would be a good time for us to double check. So, what am I supposed to plug in for x? Hopefully you know it's a 4. So we have 4 squared minus 2 times 4 minus 9. Okay? That is one way to do it. The other way would be to do 4 squared minus 3 times 4. Figure out that. And 9 minus 4. Figure out that. And when you get done, subtract the 2. So if you want to double check, you'll do the one in top that's circled in purple. If you want to use the equation that we had from the first answer, you'll do the purple part at the bottom. Find me the value when you plug in 4. Okay, so we end up with what? 16 minus 8 minus 9. What is 16 minus 8 minus 9? It is negative 1. And if you come up here and do the part at the top just to double check, let's see, that first one would be 16 minus 12. And the other one would be minus 5. And that also gives me negative 1. So we can double check our work by doing both of them. I know that some of you hate the idea of doing both of them. I understand. If you know for a fact that your answer for the first part is correct, then I don't mind you using it for the second part. No problem whatsoever. Okay, 5. I'm highlighting something in red here. Can you tell me what they're telling me to do with that part that's right there in the red? When you say distribute the negative 3, give me a little bit more information. What do you mean? Let's think about what they're telling me to do here. Give me a different answer. Okay, replace the x with negative 3 in which function? The f function. So I'm drawing 2 red arrows because you have 2 places that you need to plug in that negative 3. Now, I'm going to underline this in green. What are they telling me to do in the green part here? Place the x, or the negative 3, into the g function. So figure out the red, figure out the green, and then what am I supposed to do once I figure out the red and the green? Subtract. Right there it tells me to subtract them. So figure out the red, figure out the green, then subtract. Figure out the red, figure out the green separately, then subtract. So we figured out the red, which was the negative 6. We figured out the green, which was positive 6, and then subtracted to get the negative 12. Okay. Question 6. Tell me what I'm supposed to do, and I'll give you, we're not doing addition and we're not doing subtraction. What are we doing? We're doing multiplication, exactly. Now, I want you to write it this way, okay? I want you to write it f of 2 times g of 2. I would like you to figure out the blue part separate from the green part, and then multiply them at the end. So find the blue part first, find the green part second, then multiply them together. Try that and see what you get. Why didn't click record? So the blue part was the 14, the green part was the 3, the total was 42. Nice. Okay. Question 7. So figure out f of negative 2, the purple. Figure out g of negative 2, the red. And then multiply them together. If you have good notes taken, it'll really help on your test. If you can follow your work. So I like some of the notes you guys are showing are really good.